Dear children, now you are going to study about friction. This is the 5th lesson in your textbook, and this covers the 3rd competency level, naming as investigates the nature and uses of friction. 3 periods are allocated for the completion of this lesson. As mentioned in the earlier videos, please take the textbook closer to you. Let's begin. What is friction? It is a type of force, but it is a very special force. Why? This force applied by the contact surface to opposite to the motion. Before move far, click on the link and watch the introductory video. When does this frictional force occur? To occur this, it is necessary to have 2 surfaces and these 2 must be in contact. When the contact surfaces of the objects appear to be smooth, there is less friction, and when the 2 objects are rough, there is a great amount of friction. Remember, friction is an essential force because we cannot walk, drive safely, or stop the moving objects without friction. Let's do a simple activity to understand the concept further. Consider a situation where a table needs to be pushed along a horizontal floor. You also have the same experience in your life. When applying the force on the object, sometimes you may not be able to move it at once. So then you may ask your friend to help you to push it. In that case, you may be able to push the object to the necessary place. Think. When the object starts moving, you may feel that you need not to push harder than before. How can you explain this? As explained, when we apply force externally, the contact surfaces generate a force opposite to the direction of external force. If the object is not moving, that means the 2 forces have equal magnitude but applied in opposite direction. Therefore, the forces are cancelled out. When we increase the force to a certain point, the friction force also adjusted. But this adjustment can be done up to a certain limit. If you are able to go beyond that limit, the objects start to move because now applying an unbalanced force and that is greater than the friction occurred from the surface. Now we can introduce a definition for the friction force. The force that acts between the surface of 2 objects in contact with each other to opposite the relative motion when the objects are moving. Or else you can say it is a force to oppose the tendency to move the objects having a tendency to move relative to each other. And remember, friction exists in all 3 states of matter. But for your syllabus, we have to focus only the friction in solid matter. Depending on the situation act on a body, we can categorize the friction into three as static friction, limiting friction, and dynamic friction. Let's see one by one what are they. What is static? The word implies that there is no motion. Therefore, we can say the force exerted on one surface by another when there is no motion between the two surfaces occurred static friction. Here you can understand this person is pushing the box, so then there must be another force created from the surface opposite to the motion. That is called static friction. What is limiting frictional force? As mentioned in the first slide, when we increase the external force slowly, the frictional force also adjusted accordingly. But we increase the force further, the body starts to move. In other words, we can explain it as the frictional force that acts on the body as it just begins to move. This is the maximum friction that can be applied from the surface to stop the motion of the particular object. It is depicted here. You can see this. When we increase the applied force, the friction also increases to a certain point. So when it comes to this maximum point, thereafter the surface cannot increase its friction further. So if we apply a very small amount of force, the object starts to move. So that is called kinetic friction, and it is a constant thing. So up to this limit, the object is static or not move. So the frictional force that acts on a body as it just begins to move is the limiting frictional force. So remember that kinetic friction is less than the limiting frictional force. Dynamic friction or kinetic friction. As explained, dynamic or kinetic friction acts on moving bodies. This frictional force acted on one surface by the other when the two surfaces rub against each other and because one or both surfaces are moving. Here you can see the two surfaces are rubbed each other. In this situation, this one only moves. But in certain situation, both the surfaces are moving. As mentioned earlier, I have emphasized several times, friction is a force. So it is understood that this frictional force also can be measured by using any appliance that is used to measure the force. So here we can use the Newton meter to measure force, and the unit is Newton. Now we want to investigate the differences among the three types of friction to get a better understanding. Let's do this activity. Take a block of wood weighing 60 Newton and fix a hook-like small ring and fix the Newton balance to it. Right? Then keep the block on the table as in the figure. Pull the block by using the spring balance or the Newton balance. First you have to give a very small force, and then little by little increase the force applied to the Newton balance. Take the magnitude when each time, right? So likewise we get the readings while increasing the force until it starts to move. When you conduct this activity, you will be able to observe that to a certain point you could be able to move the block. Up to a certain point we are not able to move it. But once you go beyond that point, it would easy to move the block. So how can we reason out this? To a certain point we cannot move it because the force against the motion. We are trying to move this towards us, but the force applied from the surface to the opposite of the motion is higher than the external force. When increasing the force, this force against the motion also increases, that is exerted from the surface. When the object is about to move, at that time force against the motion is equal to the force applied from the outside. So remember that is the maximum force or the max friction that can be generated from the body and the surfaces. This is called the limiting frictional force. Remember, up to that point the object won't move. So it is the maximum friction, static friction also. When you increase the force after the limiting frictional force, or as soon as the body starts to move, you may feel that you do need much force as earlier. That means the dynamic friction is less than the limiting frictional force. I have mentioned it in the earlier slides also. Now it is time to see the factors affecting the limiting frictional force. It is better if you could watch these two small video clips to get an idea about it. It is clear that frictional force act between objects that are in contact with one another. Therefore, let us now investigate how the frictional force depend on the nature and the area of contact surface and the reaction force perpendicular to the contact surface. The activity 2 in the page 101 in your textbook is to investigate how the limiting frictional force depends on the nature of the contact area. So now you can see the figure 5.3, which is explaining how the practical should be set up. To conduct this experiment, take a block of wood weighing 60 Newton and fix the Newton balance as in the previous one. And you need some sandpapers of various roughnesses. Fix a block of wood with the sandpaper having the lowest roughness with rough side facing out and completely covering the bottom surface like this way. So you have to cover the bottom surface with the lowest roughness sandpaper and then place it on the tabletop. Then pull the Newton balance attached to the block with a very small horizontal force at first and then increase in the force gradually. Take the reading of the Newton balance when the block is about to move. or else get the value of the limiting frictional force for the particular sandpaper. Now you have to do the same activity by changing the sandpapers here. So first one is taken the least roughness, and likewise you have to increase the roughness of the sandpaper and get the value of the limiting frictional force by using the Newton balance. Now you can compare your results. What will you observe? You will observe that the values are not constant or equal. They are vary with the roughness. So we can conclude the limiting frictional force changes with the roughness of the surface or the nature of the surface. Higher the roughness, giving a higher value for the limiting frictional force. Now, as mentioned earlier, I have mentioned three things: nature of the surface, area of the contact surface, and the perpendicular reaction. Now let's see whether there is any relationship or any impact of the contact surface area on the frictional force. So for that also you have to take a wooden block having different dimensions for length, width and the height. Take a sandpaper and cover the whole thing using the same, having the similar kind of roughness, and then mark the surfaces as A, B, C, and A is having the highest area while B is having the least surface area. Then what you have to do is you have to keep it placed, you have to place the place the blocks in the way that is given in the figure. First place the sandpaper on the surfaces of the block, then place the largest surface area in contact with the tabletop and find the limiting frictional force as the previous activity. You have to repeat this activity by changing the surface areas as the diagram given. So you will be able to observe that the limiting frictional force is same for the three different surfaces. Therefore, we can conclude that the limiting frictional force does not depend on the surface area. The third one is the reaction force perpendicular to the contact surface. To investigate this dependence of the normal reaction between bodies in contact on the limiting frictional force, first you have to understand what is normal reaction. It is the perpendicular reaction force on the two surfaces. In this activity, you have to take 3 wooden blocks having a weight of 20 Newton each. As in the previous activities, keep one block on the tabletop and find its limiting frictional force first. Then you have to place one by one another block on the first one and find the limiting frictional force. Here you will observe that unlike the previous one, the readings are not similar. You will get 3 different limiting frictional force values. When you increase the weight, you will get a higher value. So that we can conclude that normal reaction is equal to the weight of the block or the blocks. By increasing the weights, we can increase the normal reaction. And when increasing the weights or the increasing the normal reaction, it will lead to increase the limiting frictional force between the two surfaces. So that let's conclude all these three activities as here. Friction depends on the material or the nature of the surface and the normal force between the surfaces. Friction does not depend on the surface area between the surfaces and the speed that the object moves. So these 4 points you have to remember thoroughly. When we consider the practical applications of friction, in some cases we need to reduce the friction, and some instances it is essential to increase the friction. So we must know how we can reduce the friction or how to increase the friction accordingly. Right? In this slides, I would emphasize some methods of reducing friction. To remove or reducing the roughness, what we have to do is we have to polish the surface. We can apply lubricants like graphite and grease and insert balls that could roll between the contact surface areas. Example, having ball bearings, thereby we can protect the machine parts by wearing off. Here this one also show you certain situations that we apply or that we try to reduce the friction. Now let's see how to increase the friction. In this first one you can see having these grooves treated tires increases the friction, and these shoes having studs also increases the friction, and wiping wet ball, kabaddi player wiping hands with sand. Here soles of shoe is grooved. So all these ways, there are various methods, so I have mentioning here very few situations that all of us have the experience in our day-to-day life. So here I wanted to think, or I wanted to make you have to think about this statement: friction is a necessary evil. Can it be necessary evil? Let's see how it is necessary and in which situations it will become evil. Friction is necessary, or advantages of friction. So without friction we cannot walk because all of us will sleep. We cannot stop the moving objects if there is no friction. Even we cannot hold anything. We cannot write on the board, or we cannot insert a nail. We cannot light a matchstick. Or for all of these we need friction. So friction is advantageous in certain situations. In the same time, friction is an evil. That means disadvantages of friction. Friction can also make speeding objects to tumble down and cause accidents. And friction makes work tedious because of the resistance. Workers need to exert more effort and energy to accomplish their work to overcome resistance. Soles wear out, tires wearing out. So we have to pay for new ones, otherwise we will slip and get met with an accident. And stone steps also wear out. Brake pad wearing off. Slow friction cause heat in the machinery, so that means the energy losses in various ways. So now we came to the end of this video. At the end of the lesson, you should be able to conduct simple activities to show the nature of friction. Explain the variations of static frictional force between two surfaces with the external force. You should be able to conduct simple experiments to identify the factors affecting the limiting frictional force. You should be able to distinguish static, limiting, and dynamic frictions. State that the dynamic frictional force acts on moving object and it is constant. And also it is slightly lower than the limiting frictional force. Now, all of us accept that friction always opposes relative motion between two surfaces. However, it is also utilized to produce motion. And all of us understood that friction is needed, essential in certain situations, and also it is disadvantageous. Thank you for watching the video. I hope you will gain some idea about the lesson. Thank you.